Uh, a good day. My name is Denise, and together with Jaco Elvino, we conduct the topic of automated alert system for authorities, rapid response for different types of calamity using an image processing. So the problem in its setting, uh, first is what kind of disasters fall under the project scope. Second is what kind of monitoring tool should be used to gather the information before alerting the proper authority. Third is what are the materials needed to build the project. Fourth, how efficient the project in the long run. And fifth, what is the project cost? So the statement of the problem of this topic is that the Philippines is subject to wide range of natural disasters. So most areas in Metro Manila are frequent affected by floods, fires, and earthquakes. So that the authorities are sometimes gets delayed to respond due to outdated alert system. So some of the reasons why rescue operations fail is that a lack of detailed informations affected by areas, and most of the times that most of the area in Metro Manila are have narrow streets. So to resolve this issue is that by using automated image processing, by sending real-time alert via mobile application, along with detailed information captured by image processing camera. So with these informations, the authorities will know what the situations looks like, what are the streets dimensions so that they can deploy proper vehicles to go first to avoid the clogging road. And as well as will be able to bring the proper tools for the rescue. What are the scopes and limitations? The system is intended to detect different items when there is disaster in the community area. So for the floods, there is a measurement in a certain area, like in the post, light post or wall. And if the reaches the threshold, the camera installed will process it and send alert to the mobile applications. So to indicate this will indicate the image and details from the area. So for example, the height of the flood, the items that the drainage or fallen trees, and fallen billboards so that the authorities and rescue team can bring proper tools to resolve the issue and save the affected residents. And example of this is for fire instance. Any form of smoke and fire detection during nighttime uh, must be submitted immediately in the BFP and will requires a verification process before the PFP will send out a notification to send rescue. This device will send the other details as well. So for example, state dimensions and crowd situation. Our next example is for the earthquake. The device will capture the fallen object and debris. Also, the vibration report will be sent to the authorities as well so that they can analyze the place most needed are rescue operations. However, the device to be used must be waterproof, a 360 camera, smoke detector, vibration sensor, will also have large volume of storage allocation and requires government agency details for data transmission purposes. So we with RRL or review of related literature is that the local based on James Andrew Sarmiento. The deep learning was proposed in this article for two of capturing pavement distresses from 2D RGB images, so detection and segmentation. On a small data set of pavement photos, YOLO V4 is utilized for pavement distress detection, and Deep Love V3 is used for pavement distress segmentations. The pavement distress detection and segmentation using YOLO and the Deep Love V3 on pavements in Philippines, road transportation infrastructure is vital for safe, rapid, inexpensive, and dependable transit throughout the country, which is necessary for a productive society. However, roads deteriorate with time due to natural environment reasons and frequent traffic routes. So pavement distress or PD detection is critical for monitoring current conditions and enable targeted restorations and preventive maintenance. Uh, Nonetheless, in developing nations such as Philippines, distress detection surveys are still conducted. So in the foreign literature is that object detection has received a lot of research attention in recent years because of its tight association with visual analysis and picture interpretation. Handcrafted feature and shallow trainable structure underpin traditional object detection algorithms. So by generating sophisticated assembles that incorporated several low-level picture features with high-level information from object detector and scene classified. Their performance quickly plateaus. So with the rapid advancement of deep learning, mostly more uh, powerful tools capable of learning semantic or high level and deep feature are being offered to address difficulties in traditional architectures. So in terms of network architecture, training technique, and optimization functions, so these models behave differently. We evaluate deep learning based object detection frameworks in this paper. So their examination begins with a brief history of deep learning in its application. So with comes in research design or methodology. This research uses an agile methodology that intends to address issues presented by previous waterfall based to providing huge items over lengthy periods of time. So a method of project management that divides the project into phases and promotes ongoing collaborations and improvement. So first, requirements, definitions, and analysis of concept. This project has prerequisite when it comes to building the object detection for its data sets and program algorithm. So for the prototype, the project requires a camera, microprocessor, and mobile. And adding up the materials that will help the object detector. So for example, the water labels, a light post, sensor modules, vibra sensor, and smoke detector sensor. So second on this agile methodology is that planning of sprints. So there will be a categorized for the step-by-step process of the project. One is for software and other category is for hardware. So the project will be used as Gantt chart for the timeline to help them meet the deadline. So third is collaborative design development. There will be collaboration between the developer and the Philippine authority involved in the project. So the surveys and interviews will be conducted to collate the data that will be included in the system concepts. So for create and implement, after ensuring all the categories from 1, 2, 3, uh, all the categories software and hardware are completed and tested, the implementations can be conducted on plan, date, and time. So for the 5, review and monitor, after the implementation process, there will be a fail back and recovery session for better monitoring and backup of the project in case of the issue of the terms.
Thank you very much, Dennis Puso, for explaining the part of introduction up to this research design methodology. Good day, everyone. Now let's proceed with the next slides. Now let's proceed with the framework of um, the disasters that we have, which is the flood, earthquake, and fire. For the flood, we're going to be using a light post for the labeling of the height of the water. Also, we'll be having a image processing for the obstacles and also the range of the houses, since we will gonna be um, checking which is the most affected area before the authority receive the alert. Here's the process. The camera will gonna capture the situation, and then once it detects the required uh, the requirements, which is the height of the water, the obstacles, and the situation, um, here it's gonna send out the alert to the authority. It will give the information about the objects it detected, which is, for example, flood, and it is 1 foot, and it will give the location and time it happens. And then when the authority receives the um, alert, they will be having a verification process to check the footage and the detailed capture of the image processing camera, which has all of the information and details in a mobile app. Next is for the fire. For the fire, the device is going to process the image of the fire, also the smoke. Once it was detected, it will going to send out an alert to the authority, which is the Bureau of Fire and Detection Prevention, and also um, the process will be for the camera to detect the disaster, which is the fire and smoke. Actually, this will be happening during the night time mostly. It is very active during the night time for the detection of fire and smoke. Also, it can capture the obstacles and the information about the area, which will gonna provide the dimension of the streets, since the firefighter vehicles need to assess which would be the first vehicle to come in. And then there will be another verification process for checking the footage and details capture of the image processing camera to just confirm the situation, and to also give them an information to bring the proper equipments like extra ladder, extra access, and etc. For the earthquake, the camera will going to detect falling debris, falling trees, also the cracked grounds. First and foremost, it's gonna detect the vibration of the ground, since that will be the first thing that it can capture. And we'll be having a dashboard for the intensity rate in the mobile app as well, that can be seen by the authority. And then also it will capture the obstacle for bringing the proper equipments to for the rescue. um and then there will be another verification process check by checking the footage and details captured by the image processing through application in the mobile. The camera will be consist of image processing process. For this, let me show you the image process, how it works. And for this one, it's gonna read the video stream, and then it will going to have an image processing or motion detection once the target object has been detected. And then it will gonna be have an analysis, also analysis for event detection, alarms through mobile application, and it'll be going to store in our cloud storage. And for the video to be not uh, having a big storage capacity, we're going to compress the video by using the adjacent QP value compression and H.264 compressed video coding. For the automated alerting system, this will be the process for the once the camera captured all of the data that we've been needing. There will be a threshold for it before it sends out an alert. If the threshold hit the three times the image three times for every 5 minutes, it will sends out an alert via call and dashboard in the mobile app. Via call that won't stop until notice, so that the authority will won't miss any alert through the disaster. If it's no, it's just gonna sense a good condition. Like if it's not hit three times. Like for example, the smoke has been detected or the fire detected two times every 5 minutes. And for the third time, it is not detected again. It won't send any alert that will cause that will have a call, and it can still send captured image or video in the mobile app, but it will not send a call alert. And then once the authorities receive the alert, they will provide the action needed. For our research instrument, these are the initial tools that we can use for building the project. First is the camera. 360 camera is the best for this project. And then we're going to use the ESP32 microprocessor or microcontroller, and we'll be having a vibration module. Also, YOLO V5 TensorFlow is being considered for the dataset library that will going to be part of our Python programming for the image processing. And SolarWinds is one of the monitoring tool that we can use, but there's also another tools that we can have, like the site scope um, and many more. For the prototype design, let's go first with the outer part. We consider the solar panels for another power source, but this is being attached to the light post, so one of the power source is the DC. And next is we produce a box due to due to the, to have an extra protection like waterproofing and heat protection, also for the the community protection like theft or by throwing stone to it. And then the material we'll be using is a fiberglass, and also we'll be coating it by nanoceramic film that being used by in the car windshield and dashboard for the for another extra protection because it can protect it from direct sunlight and also the water, um, the rain, acid rain marks for better vision. Also, the nanoceramic is dark on the outside and bright on the inside, so there will be no problem on the capturing during day and night time. And the camera we'll be using is a 360 camera, and we'll be installing as well the microprocessor inside and the modules, sensor modules. And here is the top view and front view of the prototype. Next for references, we'll be having a Sarmiento JA 2021 first project pavement distress detection and segmentation that use YOLO B4 and Deep Lab 3 on pavements in the Philippines. Also, Shongshu, Shao, Pengsheng, Shou Tao Chu, and Shu Dongwu during 2019 for their paper, which is the object detection with deep learning a review. Also, I have the Prakarp A, Garvey J, Saumya S, Shivansh G, Deepali K, Rekja J, Niraj M during 2022 for the recent project, which is the YOLO algorithm implementation for real-time object detection and tracking. So that's all. Um, Thank you very much for watching our video. Bye.